Can you monkey patch methods on core types in Python? Ruby can add methods to the number class and other core types to get effects like this. But it seems like Python cannot do this. Is this true? And if so, why? Does it have something to do with the fact that type can't be modified? Rather than talking about different definitions of monkey patching, I would like to just focus on the example above. I have already concluded that it cannot be done, as a few of you have answered. But I would like a more detailed explanation of why it cannot be done, and maybe what feature, if available in Python, would allow this. To answer some of you, the reason I might want to do this is simply aesthetics/readability. This reads more like English and clearly indicates which is the tested value and which is the expected value, as supposed to. This concept is what Respec and some other Ruby frameworks are based on.
No, you cannot. In Python, all data, classes, methods, functions, etc. are defined in C extension modules, including built-ins, or are immutable. This is because C modules are shared between multiple interpreters in the same process, so monkey patching them would also affect unrelated interpreters in the same process. Multiple interpreters in the same process are possible through the C API, and there has been some effort towards making them usable at Python level. However, classes defined in Python code may be monkey patched because they are local to that interpreter.
What exactly do you mean by monkey patch here? There are several slightly different definitions. If you mean, can you change a class's methods at runtime, then the answer is emphatically yes. If you mean, can you change a class's methods at runtime and make all of the instances of that class change after the fact, then the answer is yes as well. Just change the order slightly. But you can't do this for certain built-in classes, like int or float. These classes' methods are implemented in C, and there are certain abstractions sacrificed in order to make the implementation easier and more efficient. I'm not really clear on why you would want to alter the behavior of the built-in numeric classes anyway. If you need to alter their behavior, subclass them.
You can do this, but it takes a little bit of hacking. Fortunately, there's a module now called Forbidden Fruit that gives you the power to patch methods of built-in types very simply. You can find it at this URL or this URL. With the original question example, after you write the should_equal function, you just do and you're good to go. There's also a reverse function to remove a patched method.
Have fun, winky face.
Python's core types are immutable by design, as other users have pointed out. You certainly could achieve the effect you described by making a subclass, since user-defined types in Python are mutable by default. There's no need to make the myInt subclass public, either. One could just as well define it inline directly in the function or method that constructs the instance. There are certainly a few situations where Python programmers who are fluent in the idiom consider this sort of subclassing the right thing to do. For instance, os.stat returns a tuple subclass that adds named members, precisely in order to address the sort of readability concern you referred to in your example. That said, in the specific example you give, I don't believe that subclassing float in item.price, or elsewhere, would be very likely to be considered the Pythonic thing to do. I can easily imagine somebody deciding to add a price_should_equal method to item if that were the primary use case. If one were looking for something more general, perhaps it might make more sense to use named arguments to make the intended meaning clearer, as in or something along those lines. It's a bit verbose, but no doubt it could be improved upon. A possible advantage to such an approach over Ruby-style monkey patching is that should_equal could easily perform its comparison on any type, not just int or float. But perhaps I'm getting too caught up in the details of the particular example that you happen to provide.
If you want to support the channel, please consider liking and subscribing.